As a complement to the How to Balance in Acidic Conditions video from the module, let me show you how I would go about it. It might be more helpful to some of you that are struggling. The tables that are provided in the module are going to be what you need. So you have sulfur dioxide given. So I don't see sulfur dioxide in any of my common oxidizing agents, but if I look here, I can see that sulfide ions or sulfur dioxide goes to form sulfate ions. So I know that's how I can predict that sulfate, by looking at that chart, that that's what's going to happen. And in order to do that, I know that I'm going to have some electrons transferred here, and I know that the oxidation state for oxygen is always -2, and I have 2 of them, so that's a -4, so that must mean that this sulfur is a +4. Over here, my product, oxygen's a -2, there's 4 of them, so that's a -8. My total charge is -2, so that must mean that sulfur becomes a +6 on the product side. And so that means that I know I had to free up 2 electrons to make that happen. Now, when I look back at the chart, what happens to dichromate, I can see that it is going to be reduced to chromium 3. So I will put down that that becomes +3 form, and I know that oxygen's a -2, so that'd be -14 equals -2, so that must be 12, where each chromium here is a +6. So that means that I had 2 of those, so I'm going to make 2 of them in my product side, and they're going both from +6 to +3, so that must mean I added 3 electrons each for a total of 6 electrons needed for the chromium. Now, let's take care of what's going on with water here. To deal with that situation, I know that I started out with 2 oxygens here, and I need 4 oxygens on my product side. The source for the oxygen comes from adding in some water, and I know that I had 2, I need 4, so I would need 2 more. That also accounts for the fact that I have 4 extra hydrogens that are now free that I show on my product side. So now let's go to the reduction. This is my ox, and this is my reduction. And so here, when I add 6 electrons, 3 to each chromium, I'm going to get the chromium 3, but I need to account for the oxygens. The oxygens are going to be taken up with water. And so I had 7 to start with, so I'm going to make 7 waters. But now I have to account for the hydrogens. So I'm going to go to the reactant side and add 14 hydrogen ions. That accounts for all my hydrogens and all my oxygens, all my chromiums, and all my sulfurs. Now, let's balance electrons. In order to balance the electrons, I'm going to see that I have 2 liberated in my oxidation, but my reduction requires 6. So that means everything in this reaction needs to be multiplied by 3. So if I write my total ionic equation here, that's going to give me 6 waters and 3 sulfur dioxides, and going down to my reduction, 6 electrons, 1 dichromate ion, and 14 hydrogen ions. And on my product side, I'm going to have, don't forget to multiply by 3 sulfate ions, 6 electrons, and 3 times 4 is 12 hydrogen ions. Going to my reduction, I have 2 chromium 3s and 7 waters. Now, let's look for materials that are the same on both sides. I see on this side that I have 7 waters, and on this side I have 6. So I can reduce all 6, and we have only 1 water remaining. In terms of my electrons, I have 6 on the reactants and 6 on the product side. Remember, there's my arrow. And in terms of hydrogens on the both sides, I have 14 and 12 on the product side. So all 12 are gone, and I have 2 hydrogens. So I can show my total reaction as all 6 waters are gone, 3 sulfur dioxides, 1 dichromate ion, and 2 hydrogen ions go to form 3 sulfate ions. The 6 electrons are gone, and all 12 hydrogens, 2 chromium 3s, and 1 water. And that's another way that I like to think about how to add my hydrogens and oxygens when balancing an acidic condition.